Hello, this is Ruby. Today we're going to talk about two-tail non-directional tests versus one-tail. So the first thing we're going to talk about is the two-tailed test. When you have a two-tailed test, this means that your research question does not have a particular direction. For example, if I were to ask the question such as, does sleeping 6 to 8 hours per night have an effect on grades? Effect here would mean that it could be positive, that sleeping 6 to 8 hours could have an effect in providing me with better grades. Or it could be negative. Perhaps I'm sleeping too much and I'm not able to pay attention, and so I end up with a negative score. What we see is, in terms of statistical significance, when we have a two-tailed test, if we go ahead and we look at our curve, what we see is that for statistical significance, it has to be in the tails. And because we have a two-tailed test, the score could be an extreme score that's very small, or it could be an extreme score that is very large. And both of the green areas show statistical significance. In this case, we're going to be using a z-score. So we know that a z that's greater than 1.96 would fall in that green area, and that would be statistically significant. And a z that is less than negative 1.96 would fall in the green area, so that would be a small score, and that would be statistically significant. So essentially what this is telling you is that with two tails, there's two areas that you can look for in the sampling distribution for statistical significance. And because this is a z-test, and we're using an alpha of 0.05, and we're dividing that by 2, we get 0.025 in each tail. So that gives us a z of 1.96, and that would be a positive z of 1.96 and a negative z of 1.96. All right, now, in order for you to have that statistical significance again, it would either have to be positive or negative. If it were positive, the value that you compute for your z would have to be greater than 1.96, or the value would have to be less than 1.96. Okay, now, if we go on and we go on to our next page, what we find is we'll talk about a one-tailed test. And a one-tailed test is a little bit different, because what a one-tailed test asks is, this is a research question that has a particular direction. For example, sleeping at least 6 hours per night has a positive effect on grades. A positive effect meaning that we're expecting that if you sleep more, you're going to do better in terms of your exams. So here, what we have for a z-score is 1.65. So what you'll notice is that 1.65 is a smaller score than 1.96, which means it's always going to be easier for you to find statistical significance with a one-tailed test. That will always be the case. So in this case, because we only have one tail, the score has to be a large score. It has to be a score that's above 1.65 in order for us to have statistical significance. If you found a very small score, like let's say you found a score of negative 3.25, that would not be statistically significant because it would be too small. So here what we see is, because we have 0.05 and we take that alpha of 0.05 and we go into the z table, we find that the critical z is 1.65, and because it's a positive, we're looking for a high positive score, it would have to be greater than 1.65. The other thing to remember here is that it's always going to be the case, where the asterisk is at the bottom, that with a two-tailed test, it's always going to be harder for you to be able to find statistical significance. It will always be easier with the one-tailed test because the z critical value will always be smaller. All right, now we have one final example. And in our final example, what we're looking at is we're looking at, again, a one-tailed test that has a particular direction. But here we're saying that sleeping less than 6 hours per night will have a negative effect on your grades. A negative effect meaning that the statistical significance is going to be on the negative side of the distribution. So that would mean that we'd have to find a z that's less than 1.65. So here we're looking for an extreme value, but it's an extreme value that is very low. So it's going to be less than 1.65, and that's going to be on the negative side of the tail. Now once again here, if we were to do this particular statistical test and we found a very large extreme value, let's say a value of 3.5, even though that's in the tail, it's in the wrong tail, so it would not be statistically significant. So one of the things to remember about a directional test is that it will be only in one tail. It will only be either in the negative tail or the positive tail. The other thing to remember is that critical z-value will always be smaller than the critical z-value that you found for the two-tailed test. Okay, so that is everything. And then I'll just raise this up here so you can take a look. And essentially, I've told you the same thing again, which is that it's always going to be easier to reject with the one tail than the two tail. All right, bye-bye. Till the next lesson.